Hello students, in previous class we already discussed about what is frictional force and what are the types of friction when two solid surfaces are in contact, like static friction and kinetic friction. And static friction is a self-adjusting friction that so that it adjusts itself according to the applied force. So the maximum value of static friction is known as limiting static friction, and we already discussed how the frictional force varies with the applied force and the graph. If this is the applied force and this is the frictional force, we already discussed that the graph which varies with the applied force will be like this, and the maximum value, this is known as the limiting static frictional force. And when the body starts to move at this point, this is known as the body in motion, and here body is static. So this point to this point body is at rest, and after that body will start to move with certain velocity. So here the friction will be kinetic friction Fk, and as the applied force increases, the kinetic friction remain constant, which is depends upon what? The kinetic frictional coefficient of the two surfaces which are in contact with each other. Clear? So till this point we already discussed in the previous class. So today we are going to discuss about what is angle of friction. Okay, so today we are going to discuss about angle of friction. So what is angle of friction? For example, let us just consider if here is a surface on which a block is placed. Okay, and this block has certain mass m. Clear? And the coefficient of friction for this block and the interface of the ground is mu s. Okay, this is the coefficient of static friction. Okay, and the different forces acting on the block are the normal reaction, which is acting upward by the surface on the floor block, and the weight of the block, which is acting downward. Okay, if we applied some force, or if the block is in static condition, that means by the application of any external force, if this is F applied, the block does not move on the surface, and at this particular condition the applied force is equal to the maximum value of the frictional force, that is static frictional force, the maximum value which can for this condition. What is F frictional maximum? That is mu s mg, or which can be in bracket we can write this is mu s into n, and here n equal to mg. That's why the maximum frictional force offered by this surface to the block is how much? Mu s mg. And if at that case the frictional force is maximum, that means the limiting case, okay, which is equal to mu s mg, then this particular condition when the applied force is equal to the maximum value of the static friction, that means the condition is for limiting static case, then at this instant the resultant contact force will be this much. Let this is the resultant contact force R, and this is the normal reaction force, which is the vertical component of this resultant contact force, and this is the frictional force, which is limiting or maximum in this case. So at that particular instant, the angle made by this resultant contact force with the normal reaction, this is the angle, let it be theta, is known as angle of friction. Clear? So what is angle of friction? When a body is in static condition and the frictional force is maximum, that means the frictional force is equal to the limiting static frictional force, at that instant the resultant frictional force makes an angle theta with the normal reaction, and that angle is known as angle of friction. Clear? Understood? So when a block is in rest, here it is in static condition, not moving, static, and the frictional force is at its maximum limit, that means the condition is limiting static frictional state, then at that instant the angle made by the resultant contact force with the normal reaction is known as angle of friction. Clear? So here we can write the angle of friction. It is the angle made by resultant contact force with the normal reaction when the body is in limiting static condition. Okay, so it is the angle made by the resultant contact force with the, it is the angle made by the resultant contact force with the normal reaction when the body is in limiting static condition. Okay, when the body is in limiting static condition, at that instant the angle made by the resultant contact force with the normal reaction is known as what? Angle of friction. Clear? Because we know the resultant contact force has two components. One is along the contact surface or tangential to the contact surface, which is known as frictional force, and the other one is perpendicular to the contact surface, which is known as normal reaction force. So when the frictional force is limiting static frictional force, at that instant the angle made by the resultant contact force with the normal reaction is known as what? The angle is known as angle of friction. Clear? So here we can write what is the value of tan theta. If I am drawing this figure separately here, this is the point and this is the limiting static friction, let Fr maximum, and this is the normal reaction, and here is the resultant, this is the angle theta. So here we can write tan theta will be equal to how much? P by B, which is what is P? Fr by what is B? N. Clear? If this is theta, this will be Fr, this is 90 degree, this is N, so P by B, so Fr by N, this implies we can write tan theta will be equal to how much? What is Fr? Here Fr is equal to mu S mg or mu N, so we can write here mu S N divided by N, or this implies we can write tan theta, the tangent of angle of friction is equal to mu S, or this can be written as mu theta angle of friction equal to tan inverse mu S. You have to remember this relation. Okay, where let denoted by this is theta, where theta equal to angle of friction. Okay, clear? So what is angle of friction? The angle made by the resultant contact force with the normal reaction force when the condition is in limiting static frictional condition. Clear? Then another question arises, why we consider this angle as the angle of friction? Because the resultant can make an angle with the frictional force also, this is the angle, and there is another angle theta. So why we consider particularly this angle as the angle of friction? Why not this angle? There must be a question arises in your mind that why we consider this angle, the angle made by the resultant with the normal reaction, as angle of friction, why not this angle? So the answer is, let me clarify this. Okay, so the cause is, if like here this is the normal reaction and this is the frictional force, okay, and this is their resultant. So if we increase this angle theta, this is the angle of friction, so if this theta angle will increase like this, if I am increasing this angle for this, okay, so this is will be the angle, let me theta dash, So if this angle will increase, the frictional force is also increased, as this is the resultant. So this will be the frictional force, like this, according to parallelogram law. Clear? If we decrease the angle, if this angle will decrease like this, if this will be the resultant and this will be the angle theta double dash, then the frictional force will become this much, according to parallelogram law. So as the angle theta increases, the frictional force length increases. As the angle theta decreases, the length of this vector decreases, and we know in vector addition rule, the length of the vector represents its magnitude. So when this angle will increase, the magnitude of the frictional force will increase. When this angle will decrease, the magnitude of the frictional force will decrease. That's why this particular angle is directly related with the magnitude of the frictional force. That's why this angle is known as angle of friction. Clear? As we increase this angle, the length or the vector which represents the frictional force, the length increases, so the magnitude of frictional force increases. As we decrease this angle, for this particular case, initially the angle is this much. So for this, the particular value of frictional force will be this much. When we increase the angle from theta to theta dash, like this, the frictional force will increase to this. When the angle will decrease to this one, the frictional force again reduced to this much. That's why as this angle varies, accordingly the magnitude of the frictional force varies. That's why this particular angle is known as what? Angle of friction. Clear? So you have to remember the statement or the definition of angle of friction, and how or why this angle is known as angle of friction. Clear? And what is the new mathematical expression for angle of friction? You have to remember tan theta is equal to mu s. What is mu s? The coefficient of static friction of this contact surface, or you can write the angle of friction theta equal to tan inverse mu s. Clear? So this is all about angle of friction. Okay. So next we are going to discuss about another term that is known as angle of repose. So next will be angle of repose. Let it be denoted by alpha. So what is angle of repose? So for this, let's consider a case. This is a inclined surface. Okay, and here is a block M. Clear? And this is a rough surface having some coefficient of friction mu s. Clear? So for by drawing the free body diagram for this particular case, if this angle is some angle alpha, which is equivalent to the angle of repose, so the weight will acting vertically downward, mg. So it has two components, one along this, that is known as mg cos alpha, and another one along this direction, that is known as mg sin alpha, and the normal reaction will be along this direction, n. So the frictional force will act on the block along this direction, Fr. Okay. So what is angle of repose? So angle of repose is the minimum angle of inclination of an inclined surface at which the block will start to slide by itself. Clear? So angle of repose will be that minimum value of inclination of an inclined surface on which if we place a block, it will start to slide by itself. Clear? So what is angle of repose? It is the minimum angle of inclination of an inclined surface due to which a block placed on that surface is just starts to sliding. Okay, so it is the minimum angle of inclination of an inclined surface, maybe it will be rough. Okay, inclined rough surface due to which a block placed on the surface it just starts to sliding. Okay, so if here alpha is the angle of inclination, and for this particular condition let us assume that this alpha is equal to what? Angle of repose. Then for this case the block will just start to sliding. That means at this particular condition the block is in equilibrium condition. If we just increase this value it will slide. Okay, so just starts to slide, that means it is at the verge to slide. Clear? So from free body diagram here we can write what is N. So as the block is just at the verge to slide, so here you can write along this direction mg sin alpha equal to fr, and for this direction we can write n equal to mg cos alpha. Let it be equation 1 and equation 2. Clear? And we know what is fr, frictional force equal to mu s into n. Let it be equation 3. So using 2 in 3 we will get what? Fr is equal to mu s into mg cos alpha. Okay, so this is the value of Fr. Let it be equation 4. Now using 4 in 1 we will get what? Mg sin alpha equal to mu s mg cos alpha. Clear? So mg will get cancelled. So we will get tan alpha equal to mu s, or this implies we will get alpha equal to tan inverse mu s. So where alpha equal to angle of repose. Clear? So at this condition the angle of repose is equal to tan inverse mu s, and just previously we already discussed that the angle of friction theta is also equal to tan inverse mu s. Before here we discussed that theta is also, or angle of friction is also equal to tan inverse mu s. So from these two conditions we can write angle of repose equal to angle of friction mathematically, not actually. Okay. So mathematically angle of repose or angle of friction are equal, but actually they are different according to the definition. Clear? So the angle of repose is the minimum angle of inclination for a rough inclined surface due to which a block placed on that surface will just start to sliding by itself. Okay, so this is about the angle of friction and angle of repose. You have to remember this formula and the definition of angle of repose and angle of friction. Now let us discuss how motion will take place in an inclined frictional surface. Okay, so let's consider a inclined surface like this. Okay, this is the angle of inclination theta, and let here is a block of mass m. Clear? And let name this inclined surface as A, B and C. Here AB is given as L. That means the length of this inclined surface is L. Clear? So now drawing the free body diagram, what we will have? The weight of the block acting downward, mg. So it has two components, one is along this direction, that is mg sin theta, and another one acting along this direction, that is mg cos theta, and the normal direction is along this direction n. And the frictional force, if this surface has coefficient of friction mu s and mu k. If the body is sliding, then the kinetic coefficient of friction is mu k, and if the body is at rest, the static coefficient of friction is mu s. So the frictional force will act along this direction, Fr. Clear? So if the block is at rest, then all the forces combine to 0 if the block is moving in downward direction. So first, if the block is moving in downward direction, let it have some acceleration a. Clear? We assume that this block is moving in downward direction with acceleration a. So from FBD, what we can write? There is no motion along this direction, so we can write n is equal to mg cos theta. Let it be equation 1, because there is no motion along this direction, but as the block is moving along downward direction, so we can add mg sin theta minus Fr will be equal to m into a, equation 2. And at this case, as the block is sliding, so Fr will be kinetic in nature, so we can write Fr will be equal to how much? Mu kn, because the block is sliding, so we have to consider the kinetic frictional coefficient, so mu kn. So let it be equation 3. So now n equal to mg cos theta, so this implies we can write Fr will be equal to how much? Mu k mg cos theta. Okay. So now using this value of frictional force at this place, we have mg sin theta minus mu k mg cos theta equal to m into a. So now cancelling mass from both sides, we have the acceleration. What is the value of acceleration? A equal to g sin theta minus mu k g cos theta. You have to remember this expression. Okay, so what is the value of acceleration when a block of mass m is sliding on an inclined surface of inclination theta? That is g sin theta minus mu k g cos theta. What is mu k? It is the kinetic frictional coefficient of this inclined surface. Okay, so this is the acceleration with which this block will slide down. Clear? And as the length of the inclined path is L, so we can easily find out the final velocity at this point. So now what will be the expression for final velocity v at B? So from using equation of motion, we can calculate the final velocity at bottommost point. City at B. B is the bottommost point. So VB will be how much? Here at point A, the initial velocity is 0 because the block starts sliding from the point A. So we have U 0. What is acceleration? From here we will get g sin theta minus mu k g cos theta. So we need V. So what is the relation? And here we have the displacement is how much? L. So here S equal to L. So we can write by using equation of motion V square minus U square equal to 2AS. So by this equation we can write this implies VB square minus U is 0 equal to 2. A is how much? G sin theta minus mu k g cos theta into displacement is L. So the final velocity VB will be equal to under root of 2L g sin theta minus mu k g cos theta. Okay, you have to remember this expression. So this is the final velocity at the bottommost point B. Okay, this is L. L is what? The length or displacement along this inclined surface. Okay, let it be equation 5. So this is the expression for acceleration, this is the expression for final velocity. Now what is the time required by the block to reach at the bottommost point? How to find out the time required by the block to reach at the bottommost point? Again we have to use the equation of motion. V is equal to time required by the block to reach at point B. We know here V at B equal to U plus AT. What is U? At this case U is tends to 0. So VB equal to AT. So this implies T equal to how much? VB by A. And this is VB, this is A. So from this we can easily find out the expression for what? Time. Clear? VB by A. So this is the expression for VB and this is the expression for A. So now using 4 and 5 in this equation, we will get the time required by the block to reach at point B. Calculate by yourself by putting the value of VB and A at this equation. You can calculate by yourself what is the time required by the block to reach at point B. Clear? So now let's calculate what will be the work done by the frictional force, or what will the work done during the motion of the block from this point to this point. Clear? As the block is sliding along this direction, what is the net force acting on the block? We have the work done during sliding of the block. So work done during the sliding of block. So as we consider the block is sliding along this direction, so the net acceleration is along this direction. So what is the net force due to which the block is sliding? So we can write mg sin theta minus mu k mg cos theta. So this is the F net due to which the block is sliding along this direction. And what is the total length of, or the total displacement of this block is L. So work done equal to F dot S. So this implies you can write mg sin theta minus mu k mg cos theta into L. So this is the amount of work done during the sliding of this block. Okay, so when the block is sliding with certain net force which is acting downward direction, the work done will be F dot S. So this will be the amount of work done. Clear? Okay students, so here you have to remember that this angle of inclination is less than angle of repose, because here the angle of inclination is greater than angle of repose. As the body is sliding by itself, we are not applying any kind of external force to this block to get sliding on this inclined surface. So as the block is sliding by itself on this inclined surface, so this angle of inclination theta must be greater than what? The angle of repose alpha. So here you have to remember one point here, the angle of inclination is, or bracket, within bracket which is theta, is greater than angle of repose. Okay, so if the angle of inclination is greater than angle of repose, the block will start by itself, and for that condition, what is the acceleration of the block, what is the final velocity of the block at the bottommost point if the total inclined surface has a displacement of L, and what is the time required by the block to reach at the bottommost point, and what is the work done by most driving force for this block. We already calculated here. So now let's discuss if the angle of inclination is less than that of angle of repose. So in here we have no motto to apply any kind of external force as the block can slide by itself, but if the angle of inclination is less than that of angle of repose, so if the angle of inclination is less than that of angle of repose alpha. Okay, so if the inclination is less than that of angle of repose alpha, then we must have to apply any external force to get motion within the block. Okay, so let's discuss that motion in an inclined frictional surface when angle of inclination theta is less than angle of repose alpha. So first case, block is sliding down or moving down. If the block is moving down, so we must have to apply an external force along this direction. Let this is Fa. Because the block can't move by itself as the theta is less than alpha or angle of repose. So if we are trying to move the block in downward direction, as the block is moving down, so we have to apply an external force along downward direction. So we can write Fa plus mg sin theta equal to how much? Fr. If the block it just starts to sliding, let it be equation 1, and in this direction perpendicular to the contact surface, we can write N equal to how much? Mg cos theta, let it be equation 2, and here we can write Fr will be equal to mu k n. Okay, or if the block it just starts to sliding, we can write the maximum value of frictional force or limiting case, that is mu Sn, or this implies we can write if n is mg cos theta, so Fr will be how much? Mu S mg cos theta. At this case the block it just starts to sliding, we can write this Fr equal to mu S mg cos theta, or if the block is already in sliding or the block is sliding, so here we will write mu S will be how much? Mu k n cos theta. Okay, so if the block is at static condition or limiting case, we have to write mu S. If the block is sliding already, we have to write mu k. So Fr equal to mu k mg cos theta. So this implies we can write F applied plus mg sin theta. And in this case, this is the condition for what? This is the condition for equilibrium case, or at the point where the block it just starts to sliding. So if the block is already moving along this direction, so we have to write, or we have to modify the equation 1 like this: F plus mg sin theta minus Fr equal to ma. Clear? If the block it just starts to sliding, we have to put the equilibrium condition. But as here we consider that the block is already sliding in downward direction due to application of an external force. So we can write Fa plus mg sin theta minus Fr equal to ma. This will become the equation 1. And as there is no motion along this direction, so here we can write n equal to mg cos theta, and where Fr equal to mu k n, kinetic friction, that is mu k mg cos theta. So from this equation 1 we will get F plus mg cos theta minus, what is Fr? Mu k mg cos theta equal to ma. So this implies we will get, what is the acceleration? Acceleration equal to Fa plus mg into sin theta minus mu k cos theta divided by m. So this is the expression for acceleration when the block it starts sliding in downward direction. Clear? So here the applied force is equal to this much. Clear? Next, if the block is moving upward, moving up. So if the block is moving upward, so we have to apply an external force along upward direction. So now as the block is moving upward, the direction of frictional force will shift from upward to downward direction because the block is moving upward. So for this condition, if there is again no motion, so we can write n equal to mg cos theta, equation 2. And what is Fr? Fr equal to mu k into n as the block is sliding upward. So this implies Fr equal to how much? Mu k mg cos theta. Let it be equation 3. So equation 1 can be written as Fa minus mg sin theta plus mu k mg cos theta equal to ma. Or what is the acceleration? Acceleration will be equal to Fa minus mg into sin theta plus mu k cos theta divided by m. So this is the acceleration with which the block will moving upward if an external applied force Fa is applied on the block of mass m. And what is theta? Theta is the angle of inclination which is less than that of angle of repose. Clear? So this is how a block slides on an inclined surface when the angle of inclination is less than that of angle of repose. So now next we are going to discuss about as friction, why friction is called as a necessary evil. So why we call friction as a necessary evil? So necessary means it is mostly required and evil means it has some disadvantages. So friction has both advantages and disadvantages in our day-to-day life. That's why friction is called as a necessary evil. So what are the advantages of friction? I can able to write on this whiteboard because of friction. If there is no friction between this pen and this board, then I can't able to write. We can able to walk on the surface due to friction. Friction is the cause which help us to work on a surface. We can write, we can work, we can do any starting due to friction. Okay, that's why friction is important to start anything. If there is no friction, then we can't able to start anything. If we have to start a bike, start a car or anything that we want to move from rest to motion, the first thing is required, that is friction. That's why friction is very important to us, because without friction we can't able to perform a large number of action in our day-to-day life. Again, friction is also has some disadvantages in our day-to-day life, as due to friction tear and wear occur in the shoes, the shoe which we use in our foot, if there will be no friction, then the shoe will remain forever new. But with due time, the shoe become old and become worst due to friction. Same thing will happen to the tires of our vehicles. Same thing happen to the machineries we used in industries. Due to friction, they get damaged. So, and due to friction, there is also large number of energy losses in different conditions. Friction causes heat energy, friction causes sound energy. That's why the efficiency of the instruments that were used in our day-to-day life decreases because of friction. So as friction has a large number of advantages and also same number of disadvantages, that's why friction is known as necessary evil. You have to remember what are the advantages and what are the disadvantages of friction. So this is important, why friction is known as necessary evil. Under this segment you have to write the advantages and disadvantages of friction. Okay, so next we have to study how to reduce friction. So how we can reduce friction or method to reduce friction. So how we can reduce friction? First of all, by polish the surface. If we polish the surface which is in contact with other surface, friction will reduce. As much as the surface is polished or smooth, the friction will be reduced. Next, by lubrication. If we apply oil on the surface of friction or some lubricants like grease, then the friction also decreases. That's why we used engine oil in engine to reduce the friction. Clear? Then by converting sliding motion to rolling motion. Okay, so what is sliding motion? If I am dragging this pen on the board like this, the friction will be more because there is sliding. But if I am rolling this pen on the floor like this, there will be no friction or the friction will be very less. Clear? So when we convert a sliding motion into rolling motion, the friction reduces. For example, if this block is moved on this frictional surface with certain force F, this motion is known as sliding motion because the block M will slide over the surface, but same surface, but there is a spherical object which is rolling like this. The frictional force acting on the spherical object will reduce because this motion is rolling, this is sliding. So if we convert sliding into rolling, the friction will decrease. So these are certain methods by applying which we can reduce the friction. And in case of air friction, you must observe that the face of high speed vehicles like bullet train or aeroplane have sharp faces like this, because due to these sharp faces the air friction or air opposition reduces. This is known as aerodynamics of the fast moving vehicles, which will reduce what? The air friction. So by applying these types of methods, we can easily reduce the friction. Okay, so if we can use by this method, we can reduce the friction. How we can increase the friction? By increasing the roughness. Okay, if the surface is smooth, by applying some dust, we can convert the smooth surface into rough surface, so the friction will increase. Clear? So these are some methods by which we can reduce the friction. So basically friction depends upon the nature of the surface. So according to the old concept, if the surface is smooth, the friction will be less, and if the surface is rough, the friction will be more. But according to the modern theory of friction, you have to remember this statement as modern theory or modern concept of friction. What is this? If the smoothness of the surface is more, the friction is more. Okay, if the smoothness is more, then the surface friction of the surface is more. Why? If there is a surface or two surfaces are in contact, we already discussed previously, according to the old theory, the contact surfaces applied some force that is known as contact force, and the tangential component of this force is known as frictional force. So if the surface is rough, so the force have some tangential component, and that tangential component combined to give the frictional force. But if the surface will be purely smooth like this, okay, then the intermolecular force of attraction between these two surfaces A and B acts at each and every point. That means each particles on the surface of body A and each particle on the surface of body B are in contact with each other. In this case, some particle or some point of body A and B are in contact with each other, due to which there is a frictional force exists. And if we smooth the surface, the tangential force will decrease. But according to modern theory, if the smoothness of the surface is more, the friction is more. Why? Because if the surface is completely smooth, then each and every particle present on the surface of both the bodies A and B will be in contact with each other. So according to the electromagnetic force of attraction between these two particles of both the bodies, maybe that is cohesive or adhesive force. We will discuss what is cohesive and adhesive force in further lectures. But here you have to understand that the force of attraction between the two particles of the two bodies will act in each and every point. That's why the force of attraction between these particles will be more. So it will be very difficult to slide the bodies over each other. That's why if the surface will become highly smooth, the friction will increases. And you must see in the MotoGP racing, the tires of the bike are purely smooth, they don't have any grip, and the road is also very clean. That's why they can incline up to maximum angle of inclination, and they can drive their bike up to very high speed. Clear? So as the tire is smooth and the road are also very clean, so there will be maximum friction exist between the tire and the road in MotoGP racing. That's why the rider can ride the bike with very high speed. And you can observe that in case of road, if there is some dust particles, it will become more slippery. In case of the road is very plain, then there will be less slippery condition. Why? If the dust particle arises, then the sliding friction, or there will be some particles along this contact surfaces which will act as wheel or rolling. That's why the frictional force reduces and the particle easily skid or easily slip. Okay, so this is the concept of modern theory regarding friction, that if the smoothness of two contact surfaces is very high, then in case this, the frictional force will increases. But if the surfaces are slightly smooth, then the frictional force will decrease. Clear? So this is all about your friction. how frictional force exists and what are the types of friction, how frictional force create motion, how it stops to move a body, and what is the modern concept of friction. If the smoothness of two bodies or two contact surfaces increases, it will cause in increasing the friction. Clear? So next class we will discuss further. Thank you.